My name's Shona. I'm a senior design engineer at Dyson. Just to let you all know that this is being recorded for internal use only. If you can all make sure your microphones are muted. There will be time at the end if you have any questions. So I'm here representing the James Dyson Foundation. This is Dyson's charity that exists to inspire the next generation of engineers. I'll talk to you about the engineering that goes into a lot of our products, a little bit about my own engineering career, and I'll talk about the Foundation's annual design competition, the James Dyson Award, which hopefully that's what you're here for. It could be your opportunity to kickstart your career and the start of your invention's road to commercialization. So the James Dyson Foundation exists to inspire engineers. There's a massive shortfall of engineers today. 186,000 engineers needed annually. Just a reminder to mute your mic. So we've got this massive shortfall of engineers. And also with a lot of younger people who don't really know what engineering is or what engineers do, and we're trying to address that. So one of the things that the foundation does is to go into schools and ask young students to draw what they think an engineer looks like. And a lot of the pictures that come back look like this. You've got a man in dirty clothes fixing an appliance. And this is a valid form of engineering, but we want to show young people how diverse and exciting the world of engineering is, that it's more than just this. We provide free engineering educational resources, and we run workshops all over the place, led by design engineers, to introduce young people to the exciting world of engineering. Alongside the foundation, the foundation supports charities local to the Dyson offices and also medical research. And then, of course, we also run the annual design and international design competition, the James Dyson Award. So the countries highlighted in orange are where the foundation operates in the UK, the US, Japan, Malaysia, and Singapore, and in the Philippines. And the blue countries and orange countries together represent the 28 countries and regions where the foundation runs the James Dyson Award. So a quick bit about me. So I graduated with a degree in industrial design and technology from Loughborough. I didn't really have a specific career path in mind, but I knew what I enjoyed, and I enjoyed designing and working with materials. So after graduating, I took a job doing mostly CAD design. And then after a few years of that, I moved to Dyson in 2014. And I've been working in the hair care category. And I've learned a huge amount since then, with some very, very diverse work from CAD design and building and testing prototypes, developing test methods, running user trials. I'm now working as a UI and UX engineer, developing and defining user interactions of our products. And I've also been fortunate enough to be involved with some of the launch events we do, particularly for the Air app, where I've had some time on stage and on camera as well. So it's been a lot of fun. A lot of the work the James Dyson Foundation do is based on engineering processes that we practice at Dyson. And this is the engineering ethos of Dyson. It's something that we use to judge what makes a really great James Dyson Award entry. So at Dyson, we have over 6,000 engineers globally and scientists. We all work in RDD, which is research, design and development. And this is the heart of Dyson. This is where we come up with ideas and concepts and tests, where we research, experiment, prototype, refine and test again. And this is where we develop the technology that solves problems. Before I talk to you some more about engineering at Dyson, I've got a video to show you. So let's start with a global update of where Dyson is today.
In a way, problem solving is a disease. Although each one's a headache, it's there to be solved.
Oops.
Dyson has moved the goalpost again.
Dries hands in just 10 seconds.
Lighting products that track natural daylight.
This is technology that can improve lives. What we're doing is trying to do something different and better. In a way, problem.
So it's pretty exciting stuff. At the moment, here's some numbers for you. We've got 100 million Dyson owners worldwide, people who own our products. And as I said before, 6,000 engineers and scientists spread all over the world. At the moment, we have 150 undergraduate engineers at our Dyson Institute of Engineering and Technology, DIET. Across 83 markets, we have over 10,000 patents, and we're always developing new ones. And currently, we manufacture one machine every 2 seconds. So as you can see, our research teams are based all over the world, from developing battery technology in Michigan to motors development in the Philippines and software and product trialing in Shanghai. We've got some excellent facilities globally. Here in the UK at Hull Avington, we focus on environmental care and robotics. Our tech center in Shanghai is our first dedicated RDD space in China. Here we're doing software and machine trialing, and research teams are dedicated to understanding air quality. In Malaysia, we first established over there in 2000. We now have only over 1,200 employees there working at the Malaysia Design Center. And in the Philippines, we have a motor manufacturing line, which was launched in 2016. And we're now growing our software presence there as well. So how did Dyson become this massive global technology company? It all started with a problem with a vacuum cleaner. And James Dyson's first invention, which was the dual cyclone technology, which was developed to solve that problem. His invention increased the vacuum suction power, removed the need for a single-use consumable bag, and 5,127 prototypes later, James created DC-01, the first bagless vacuum cleaner. This was pretty groundbreaking at the time, not only because it solved this problem, but it was also the first vacuum cleaner that showed the dirt with a clear bin, and this was very controversial at the time. But now you'll struggle to find one that doesn't do this. It still wins awards for its design, even to this day. And now if you look at the evolution from where we started back then to the latest 315 cordless vacuum cleaner, we've gone from corded bulky machines to light, efficient, cord-free machines. This latest vacuum uses lasers to make dust and dirt visible. It has an LCD screen that tracks what the vacuum picks up, as well as battery life and mode. These machines are a fraction of the weight, use fewer materials than corded machines. They use lots of less energy, but they offer the same performance. So the design process practiced at Dyson allows us to improve technology in this way. So everything starts with a problem. Design engineers think of ways to address the problem by developing a cycle of ideas. We create prototypes, test them, see what different ways the problem can be tackled. There are lots of frustrations and problems along the way, and this is never an easy, simple process. But it's what we learn as we go through this iterative cycle of design, build, test, iterate, design, build, test. We uncover new challenges and problems to address, and we learn from previous mistakes to apply solutions to more recent prototypes. And we just go round and round until we get, for instance, something like this. So the Dyson Supersonic hairdryer, you see it as a final product like this, but to get to that point, it was about 5 years of this. This is just showing you about 11 of the more than 600 prototypes that were built and tested using materials from cardboard, plastic, metal, over nearly 5 years. So these are all developed specifically to test out certain problems throughout the product and to test and measure the performance of it as we develop that through its life stages. So it looks quite linear and smart when it's laid out like this, but it's not always, it doesn't always happen in that nice consecutive order, but eventually you get to your final product. So Dyson solved a lot of products, a lot of problems in this way. And today we span so many different products that you may have seen, you may own. Our air blade technology and our hand dryers, we dry hands in a faster and more hygienic way, whilst also using less energy than conventional warm air hand dryers. And it also does away with single-use paper towels. We've got our purifier range to improve indoor air quality, to ensure that your homes are clean and safe. We've got Dyson lighting, which was founded by James Dyson's son, Jake Dyson, and this joined with Dyson as a company in 2015. This is developing light quality that mimics natural light cycles, and the LEDs and the technology used can last decades. So you can see from the range of all these different things, this iterative design process, Dyson engineers are continuing to evolve technologies to make better and better machines that solve real problems. So this problem-solving mentality is what informs the Foundation's annual design competition, the James Dyson Award. So we want to challenge current engineers or students who have recently graduated within the last 4 years to design something that solves a problem. So the next few slides are going to talk you through the James Dyson Award, what the prizes are, and some tips on what we look for in a winning entry, if you're interested in entering. So the brief is really, really simple. Design something that solves a problem. The best entries, the entries that win, put the problem they're solving at the forefront of their design. So the prizes. Each country will have a panel of external national judges to select a national winner and 2 runners-up. So national winners in each country will receive £2,000. A panel of Dyson engineers will then select an international top 20 from all of the national finalists. And then Sir James Dyson will personally select the international winner from these 20, who will win £30,000 along with £5,000 for their university. And there will be 2 international runners-up who will each receive £5,000. At the international stage, we also have now introduced this sustainability winner, and this awards the best sustainability-related entry, and that will be £30,000. But as well as the prize money, it's not just about the prize money. You'll also get international exposure for your design. The global media exposure is really what helps you to boost your profile and could secure you further investment. So I've got another video to show you now.
Design awards are usually about making products that look beautiful, but that's only a tiny part of the story. For me, the importance of the award is to solve a problem. Question things, challenge things. I've always truly believed that young people want to change the world, and that's absolutely right, they should do. And it gives them the confidence that they can literally do that. Winners get the notice they need to move forward with their idea. And I think it gives investors confidence as well.
These are some of the 2020 winners. These are the international winners. The international winner was the Blue Box from Spain. This is an at-home breast cancer testing device that uses a urine sample and an AI algorithm to detect breast cancer via an app on a user's phone. The sustainability winner last year was Aureus from the Philippines. And this is a new material made from upcycled crop waste that can capture UV light and convert it into electricity. It can also be attached to pre-existing structures like tall buildings and windows to generate electricity. The international runners-up were Scope from Canada and the Tyre Collective from the UK. Scope is a new form of camera lens that uses liquid crystals and electricity to automatically tune the camera lens to allow for greater focusing and picture quality. And the Tyre Collective I won't go into because we've got Hugo from the Tyre Collective to talk to you in a moment. So all of these finalists have received prize money and extensive international media and exposure, which will help them to progress with their inventions. All 4 of these finalists are continuing to work on their inventions and develop them into successful commercial businesses. So yeah, watch out for those. In fact, 65% of our past international winners have launched their own businesses. 20% of all past winners have launched their own businesses. The international winner from 2019, Marinatex. This is a new form of bioplastic made from organic waste from the fish processing industry. And using that along with some red algae, the 2 components bind together to create this strong, flexible, transparent material. And the idea is that this can be used as an alternative to single-use plastics in things like food packaging. It can biodegrade in a home compostable environment in just 6 weeks, so it doesn't need its own waste management infrastructure. Since winning the award, Lucy, as you see here, she says her life has massively changed. She's pursuing Marinatex full-time now. She has new office space now and interest from around the world. 2017 UK winner, Petty Ply. Ryan was inspired by the James Dyson Award presentation, just like this one, to be more creative in his final year project. He was an aeronautical engineer master's student, and he submitted Petty Ply to the James Dyson Award, which is a type of a form of child's clothing that uses folding technology to allow the clothes to expand and grow as the child grows. The idea being that this is reducing waste in the fashion industry, especially with children who grow so fast and get through so many clothes. Since winning the award, he's founded his own company. He also travels around the world speaking at events about fashion and technology. So as I mentioned, I'd like to hand over now to Hugo from the Tyre Collective, who was the 2020 international runner-up, to talk about their experience and what they've been up to since winning. I'll let you take over, Hugo.
Thank you. All right, let me just share my screen quickly. Is that playing all right? Just double checking.
Yeah.
All right, perfect. So yeah, hi, I'm Hugo. I'm a recent graduate of the Royal College of Art and one of the co-founders of the Tyre Collective. And together we were last year's international runner-up for the Dyson Award. So we all know tyres were down, but never really consider where it all goes. We started looking at microplastic pollution, and then we were shocked to learn that tyre wear is actually the 2nd largest microplastic pollutant in our oceans, which is toxic to both marine life and is present in the food we eat. This deadly dust is unique and especially dangerous because it is not only a microplastic pollutant, but also a source of air pollution too. So as an air pollutant, we inhale these particles, which can lead to heart and lung diseases. So to put that in context, today, 500,000 tonnes of tyre wear particles are produced annually across Europe. The box you see here on the left, roughly the size of a grapefruit, is how much the longest bus route in London produces in just 24 hours. This really challenged our perception of vehicle pollution, because when we talk about zero emissions, it's always been focused on the exhaust. But as we adopt electric vehicles, exhaust emissions will drastically reduce, but tyre wear will increase due to the added battery weight and torque. So that's where we come in. The Tyre Collective is an innovation company building solutions to save our air from tyre wear. We are spearheading tyre wear capturing and monitoring, accelerating the shift towards zero emission mobility. We're currently developing a retrofittable device capturing at source, right at the wheel, to prevent these harmful particles from entering our ecosystem. Once captured, these particles can be reused in new tyre production and inks and dyes, creating a closed loop system. This project would not have been possible without our course between Imperial and the Royal College of Art, which brought together people from across disciplines to work together to solve complex problems and issues through design. So my background is in mechanical engineering, having previously interned at Dyson. But you also see here the other team members, so that's Deepak, Siobhan and Hansen. And the more we researched this project, this topic, the more obsessed we became with trying to come up with a solution towards it. So let's go back 18 months and see where it all began. So as a team, we're very R&D focused. We love to build and explore through making, and that's kind of exactly what we did. So what you see here is just kind of a snapshot of our studio over the course of 3 months. And our eureka moment came when we first rubbed a balloon against a jumper and we saw these particles jumping up and down. And that's what led us to the theory that the particles themselves could become charged and that we could use electrostatics to capture them. To prove this, we built our functional prototype and test rig, which you can see here on the right. And as a university project, it culminated with our RCA work in progress show, where we revealed our invention to the public for the first time. And really, it was the enthusiasm of those we spoke to was such like a highly rewarding experience, and it sowed the seed that could this project go further? Could it be more? But then lockdown happened, and the effects of COVID-19 happened, took hold on the UK, and we were plunged into a kind of strict lockdown. But far from deterring us, the lockdown actually forced us to focus on the wider business case behind the device and reach out to the relevant people in industry. And then came the Dyson Award. So for us, the Dyson Award has always been really synonymous with innovation, and we've really admired its previous winners. So when we first received the email telling us that we'd won, we all virtually turned to each other in complete shock. And what followed was totally surreal. So just in 6 months earlier, we were filming our own little project video to try and explain what it is that we'd made. And then we suddenly had a crew surrounding us, filming us. And the team at Dyson were amazing. They secured us loads of press coverage, and their video amassed over 20,000 views in just 24 hours. So in total, we had over 70 pieces of coverage printed in 3 national newspapers and reached an estimated 1.9 billion people globally. And then in quick succession, we also won the Mayor of London Entrepreneurship Environmental Award and were notable finalists in the Core 70% Design Award and Fast Company Innovation by Design. And it was really these awards and recognition that help us raise public awareness on tyre wear and increase our company profile and push our mission across international media platforms. And it's been a gift that keeps on giving. So recently we were named Forbes 30 Under 30, alongside taking part in 4 days of filming for a new top secret documentary. So since winning the Dyson Award, we have received tremendous inbound interest from global tyre and vehicle manufacturers, and have had the privilege to collaborate with them to develop our device to improve capture efficiency. And the aim is to have our first on-vehicle working prototype later this year. In parallel, we're trying to contribute to ongoing research, working with leading academic and government organisations to run experiments and fill the knowledge gaps. So that includes characterising tyre particles, taking in-depth toxicology tests, and advancing technologies in testing to get more accurate test rigs and identify markers in order to identify this tyre wear. So we're trying to shift the focus away from exhaust towards non-exhaust emissions. In parallel to ongoing research, there's a need to start developing solutions, and we really welcome others to join our journey. So today, with the support of grant funding, we continue to scale up, and we're now testing our new prototypes on a full-scale rig, one step closer to our first on-vehicle prototype. Our team is expanding and we're about to close our first investment round. Much of this is still top secret, but we hope to have exciting updates for you soon. So in summary, the Dyson Award was really a slingshot to success. It supercharged our business by attracting the attention of global tyre and vehicle manufacturers, and above all, gave us the confidence and validation that our idea had the potential to make a real valuable impact. On behalf of the team, I really want to thank everyone at Dyson who worked tirelessly on our behalf. And good luck if you've already applied, and if you haven't, please don't hesitate to just fill out the form and put an application in this year. You never know where the journey is going to take you. So yeah, thank you so much for your time, and I'm happy to answer any questions you have at the end, or feel free to drop us an email and follow us on whatever on Instagram. Yeah, thank you very much.
Amazing, thank you, Hugo.
It's all right, let me just...
There we go, jump back in. So how can you enter? 1 second. No. That'll do, okay. Technical issues, 1 second. Cool, okay. So you can enter online at the James Dyson Award website. General rules are you must be currently studying or have recently graduated in the last 4 years, an engineering related degree course. You can also enter up to as part of a team of up to 10 members. Got another video for you now with some hints and tips about what makes an award-winning James Dyson Award entry.
We can't hear anything.
Sorry about that. Let me just do that again. Thanks for telling me. It's not the first time it's happened. Okay, this should be
Hi,
good now.
I'm George Oram, a design lead for Dyson and a James Dyson Award Top 20 judge. I'm here to offer you some insight into what makes a really great James Dyson Award entry. Firstly, as a judge, I look for something that clearly meets that brief. Design something that solves a problem. The brief really requires considered thought, and that solution has to be compelling. We want to know how that invention is different and how it is making a difference to people's lives. Secondly, communication is key. As a judge, I have a lot of entries to look at. Video and photos really help your entry stand out. If they're taken on a smartphone, that's great. Thirdly, we want to see that iterative development process, something that we really practice here at Dyson. We're not just looking for finished products, we're looking for entries that show potential, understanding how you go from that start to the finish. I really look forward to seeing your entry. Hi.
Okay, so when you submit an entry, you'll be asked to provide answers to the questions listed here. Try to provide very clear and concise answers. The judges are particularly interested in the problem that you're addressing, and specifically how your invention works to solve that problem and why it's different to other solutions out there. This will demonstrate why your invention is important and worthy of that prize money. The judges are also interested in your design process, like the one I described, the one we practice at Dyson, that iterative design process. So make sure to provide evidence of your prototyping, your testing, your development work. We do understand at the moment that the COVID-19 restrictions and things have meant that many of you have not had access to labs to produce prototypes. But the judges will bear this in mind. If you can't provide prototypes, then sketches and CAD designs are great. A good tip is to create a short, even just a 30-second video about your invention, just to help capture the judge's attention. So here are the key dates for 2021. Entries are open right now. So make sure to get your entry submitted via the James Dyson Award website by 11 p.m. on the 30th of June. One good tip is to save your entry as a Word document first. So if the website crashes or if it's overwhelmed with entries, you don't lose all of that work. Okay, so are there any questions either for myself or for Hugo about the Tyre Collective or about the award? Feel free to come off mute and jump in. Or in the chat either, I'll check.
Hi.
Oh, sorry. Thank you so much for the presentation. It was really interesting. Just to double check, does it specifically need to be for engineering designers, or can it also span into textiles and fabric designers as well?
I think it's a fairly broad spectrum, so I believe that would be acceptable. It might be worth dropping an email just to be sure, but I believe it's quite a broad, as long as it is engineering related.
Thank you.
Sorry, that's not the best answer ever, but worth checking.
Hi. Thank you very much for the talk. I was just wondering what you recommended doing with intellectual property, whether you try and secure intellectual property before you announce your invention to the world or not, and how that works with the competition.
It's entirely up to you. You don't need to secure any property rights, but it's you would have to do that on your own, because by submitting an entry, you're confirming that you're the owner and licensee of all of that intellectual property. Dyson will not take that away from you or claim it from you, but by submitting it, then you are allowing it to be viewed publicly. So it's not required, but it's entirely up to you about securing that before you submit it.
Thank you.
Also, just to add to that, so when we applied, we had our patent filed before we applied to the James Dyson Award, but also that filing is actually a very simple process and something you can do relatively cheaply on your own, and that gives you kind of a 12-month period that you can kind of keep adding bits to it. So it's worth like talking to a patent lawyer if you can, but if not, it's not a hugely overwhelming process to go along with yourself.
Oh, I'm pleased to hear that. Thank you.
There's a question for you, Hugo, here. Is there a difference in use between fossil fuel powered cars and electric cars? I'm guessing in terms of the waste they produce.
Well, yeah, just focusing on the tyres, I suppose. So the main difference is that actually electric cars are heavier and they have a higher torque. So that means there's a greater chance of kind of slip and greater friction as well with the road, which means that more of the particles are produced. But also, it should be clear that doesn't mean we're not advocating for the transition towards electric vehicles. It's just something we should bear in mind, so we're not looking back in 10, 15 years time and saying, why didn't we try and address this problem at source rather than like wait until it's too late. But yeah, I mean, there's obviously other big differences as well between them. But yeah, that's the specific tyre related one. And then just moving on to that next question. Yeah, so we are working with some car companies and tyre companies as well. I can't go into the details of that, but that's who our on vehicle testing is going to be done with later this year. But yeah, there should be some exciting collaborations in the future. So I don't know, if you're interested, follow us on Instagram. We might give you some updates in the near future.
I had a question for you actually, Hugo. Do you find that it varies around the world? Like if you're in a very dry climate, is it a bigger problem? Or if you're in a wetter climate and all of that particles are just going into the water system, I guess it's easier to catch if it's drier?
Yeah, I think from a capturing point of view, it's definitely easier if it's drier. And when it's wet on the ground, then actually the coefficient of friction is less, so less, like fewer particles are produced. But we are seeing that this is really a global problem. So in the last years since we started this project, we've seen major studies in San Francisco talking about how tyre wear has caused the mass die-off of salmon, and also more studies are going on here in London as well. So it's definitely an emerging topic and exciting area to be kind of working in.
Hi, I had a question. I was just wondering, have you looked at any ways to remove like the tire residues from like near the road surface?
Yeah, so I think so early on in our development, when we were still at college, we looked at, could we either, redesign the tire itself, or could we, were all the different points in which we could make that intervention. I think for us, we decided that by intervening at the drain or at the roadside, it becomes also quite difficult. Obviously, there's a lot more contaminants there that are present and a lot more water and other things. But it's definitely something that could be looked into. And I believe some people are looking into it. So yeah, I don't know if that answers the question, but yeah, definitely.
Is there anything else from anyone? Obviously,
Very interesting.